Hey everyone and welcome. Today we're tackling a really classic LeetCode problem, number 11, called Container with Most Water. It's a great problem that has a simple, slow solution, and a really clever, fast one. We'll break down both so you understand the logic inside and out. Let's get started. Okay, so here's the problem. We're given a list of numbers, and each number represents the height of a vertical line. Our job is to find two of these lines that, along with the x-axis, can form a container that holds the most water possible. The key thing to remember is that we can't slant the container. So to put it simply, we're looking for the maximum possible area. We get a list of heights, and we have to choose just two of them to be the sides of our container. Our task is to pick the perfect pair that gives us the biggest water holding capacity. Now how do we figure out the area? Well, the width is just the distance between the two lines we pick. But the height is the tricky part. A container can only hold water up to the level of its shortest side, right? If one side is tall and one is short, the water will spill over the short side, so the effective height is always the minimum of the two heights we choose. The area is simply that height multiplied by the width. Let's look at the example from the problem description. The input list is shown here. The optimal solution uses the line with height 8 and the line with height 7. The distance or width between them is 7 units. The height is limited by the shorter line, which is the one with height 7. So the total area is 7 times 7, which equals 49. Just a quick heads up. We'll be walking through the solution using Python, but don't worry if that's not your main language. The logic is the most important part. I'll be showing the full code for other popular languages like Java, C++, and JavaScript towards the end of the video. Okay, so what's the first idea that comes to mind? Usually, it's the brute force approach, which basically means, let's just try everything. We can set up a pair of loops. The first loop picks our left line, and the second loop picks every possible right line. For each pair, we calculate the area and check if it's the biggest one we've found so far. Simple, but is it fast? And here's what that brute force idea looks like in code. We initialize a max area variable to 0. Then we have our two loops. The outer one goes from the start, and the inner one starts just after the first one to form our pairs. Inside we find the height, which is the minimum of the two line heights, and the width, which is the difference in their positions. We calculate the area, and then use the max function to keep our max area variable updated. Finally, we return the result. So what's the problem with this approach? It's all about that time complexity. Because we have a loop inside another loop, we call this big O of n squared. This means the number of operations grows exponentially as the input size grows. If our list of heights gets just 10 times longer, the work our computer has to do gets 100 times bigger. For large inputs, this will be too slow and will time out on LeetCode. So there has to be a better way. And there is. It's a classic technique called the two-pointer approach. The core idea is to start with the maximum possible width, using the very first and the very last lines in the array. From there, we'll intelligently shrink this window, trying to find a better container. Let's really break down the logic here, because this is the aha moment. We start with a left pointer at the beginning, and a right pointer at the very end. This is our starting container. It has the largest width we'll ever see. Now think about it. As we move the pointers closer, the width is guaranteed to decrease. So if we want any chance at all of finding a bigger area, we absolutely must find a taller height to compensate for the smaller width. The current height is limited by the shorter of our two lines, so it makes no sense to move the taller line's pointer. The height would still be limited by that same short line. The only logical move is to discard the shorter line by moving its pointer inward, hoping that the next line we encounter is taller. Here is the full code for the two-pointer solution. It's much more concise. We'll set up our variables, loop as long as the pointers haven't crossed, calculate the area, and then, this is the key part, move one of the pointers. Let's break this down piece by piece. First, the setup. We create our max area variable to track the best area we find. Then, we initialize our two pointers. The left pointer starts at index 0, the first element. The right pointer starts at the last element's index, which is the length of the list minus 1. Our main logic is inside a while loop. This loop will keep running as long as the left pointer is to the left of the right pointer. As soon as they meet, we've checked all possibilities and we can stop. Inside, we do the same area calculation we did before, find the minimum height, calculate the width, and multiply them. Then we update our max area if the new area is bigger. And here's the magic. This is the crucial decision. We check which of our two lines is shorter. If the height at the left pointer is less than the height at the right pointer, we've found our limiting factor. We move the left pointer forward one step, hoping to find a taller line. If the right line is shorter, or if they're equal, we do the opposite and move the right pointer back one step. This single decision is what makes the algorithm so efficient. So how fast is this new approach? It's big O of n. This is fantastic. It means we make a single pass through the array. The left and right pointers start at opposite ends and move towards each other, but they never go backward. So in total, we only look at each element once. This is way faster than the n-squared solution, and it uses no extra memory, so the space complexity is constant, or big O of 1. Alright, as promised, here is the full solution in Java. You can see the logic is exactly the same. We initialize our pointers and max area, loop while left is less than right, calculate the area, and move the pointer that corresponds to the shorter line. Feel free to pause here to take a closer look. Next up, here is the C++ version. Again, it's a direct translation of the same two-pointer algorithm. We're using a vector of integers, but the core logic of initializing pointers, calculating area inside the loop, and then intelligently moving either the left or right pointer remains identical. And finally, here is the solution in JavaScript. The syntax is a little different, but the heart of the solution is unchanged. We have our max area variable, our left and right pointers, a while loop, and the same conditional logic to decide which pointer to move. This really shows how the core algorithm can be applied across different languages. So let's wrap it up. We saw two ways to solve this. The brute force method is simple to think of, but its n-squared time complexity makes it impractical. The two-pointer approach is the optimal solution. The big takeaway is the clever logic it uses. By starting with the maximum width and always moving the pointer of the shorter, limiting line, we efficiently search for the best possible container in a single pass. If you enjoyed this problem and want to keep practicing, the learning doesn't have to stop here. I've organized all my video solutions into handy playlists. Whether you're looking to grind through more LeetCode easy, medium, or hard problems, or you want to master a specific topic like sliding window or dynamic programming, I've got a playlist for you. It's the perfect way to focus your study sessions. Go to the Playlist tab and find a playlist that fits your goals. Also, if you're looking for even more LeetCode problems beyond the daily challenge, I've started a second channel called LeetCode Unlocked. It's where I'll be posting solutions to a ton of other problems, so if you're serious about your interview prep, be sure to check it out. The link is in the description below. Hope this LeetCode solution breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. Make sure to turn on the notification bell so you know straight away when I upload a video, because I upload videos daily. This channel doesn't make any money from sponsorships or ads yet, so if you're feeling generous, there's always the Boba Fund. Keep coding and I'll catch you in the next one.